In this video, we are going to find and use some applications of exponential functions. We are going to talk about compounding interest and investing in different kinds of accounts with different interest rates and things like that. The function that we are going to use is A, which is going to be your end amount, the end amount of money you have after a certain number of years, equals P, which is your principal, that's going to be the amount that you're starting with, then times, or open parentheses, 1 plus R over N. R is going to be the interest rate, and we're going to put that in decimal form. The N is going to stand for the number of times it is compounded per year. For example, quarterly would mean it would be compounded 4 times a year, and semi-annually would mean 2 times a year. Then the exponent of the function is n times t. The t is going to be the number of years that it is invested. So let's look at one of these problems. All right, in this example, suppose that $61,000 is invested at 4.5% interest compounded quarterly. The first thing we're going to do is come up with a formula, and then we're going to use that formula to find out how much money is in this account after different amounts of time or years. So our formula that's going to give us the end amount is A of T equals the principal. That's how much money is invested. So that's going to be 61,000 times 1 plus, now we need the interest rate in decimal form, 4.5%. So 4.5%. What we need to do is to change this to decimal form is to move this decimal 2 places to the left and then fill in the blank with a 0. So 4.5% in decimal form is 0.045. So I have 0.045 over the n. The n is the number of times it's compounded a year, and this is compounded quarterly, so that would be 4. Then close, and then n times t. The n again is 4. The t I don't know. That's what I'm going to be changing from one part of the problem to the next. Now, when you put this in MATLAB as the formula that you are going to use, it does not like what is in that parenthesis to be like that. It wants you to figure out what that decimal is. So in other words, A of T equals 61,000. Then over here in my calculator, I'll just put 1 plus 0.05, excuse me, 0.045 over 4 to see what that is. So that is that decimal, 1.01125 to the 4t. That is the formula that we are going to use. Now it's going to ask several different years. So how much money is in the account after 0 years? So here's what you are going to be changing. You are just going to be putting in, different numbers for the year, which is this. So after 0 years, you are going to have A of 0 equals 61,000 times 1.01125 to the 4. Now here's what we're changing. The t is going to be a 0. So if I multiply those exponents together, 4 times 0 gives me 0. So I'll have 61,000 times 1.01125 to the 0 power, because 4 times 0 is 0. And then we will put that in our calculator. So 61,000, open parenthesis, 1.01125, close. Now go up into your exponent, and your exponent is 0, and hit enter. Well, I still have $61,000 because I just put the money in. It's been 0 years. You haven't made money because you just went to the bank and put the money in. So after 0 years, you still have 61,000. So what about after 2 years? So what we are changing here is that. So now it's going to be 2 years. I am finding A of 2. So now when I multiply my exponent together, I have 4 times 2, which gives me 8. So let's see what that will give me by going to my calculator. So 61,000 times 1.0125, close. Now go up into my exponent, and now my exponent is 8. And we are going to round this to the nearest dollar. So I have 67,373.6, which means since this, 0.6. So since this is greater than 5, that means you're going to round that dollar amount up to $67,377. So let's say now your money has been invested for 10 years. So again, what you are changing is the number that you're putting in for the t. You are going to change it now to 10. Which means your exponent will be 4 times 10. So my exponent now will be 40. So same thing in my calculator, 61,000, open, 1.0, looking at my last one, look what I did there. I left out one of the ones, so let's go back and do that one again. Sorry about that. So I'm doing the one that had the exponent of 8 again, because we had 4 times 2, which gave me 8. So I'm doing this one again because I left out one of those ones. So 61,000, open, 1.01125, close it. Now go up and put the 8 in the exponent. So I have 66,711 after 2 years. I'm not going to round that 11 up because it's 0.1 after the decimal. So now let's replace the x in the exponent, or the t in the exponent, with the 10. So now we're looking at after 10 years, which means my exponent will be 40. So same thing, 61,000, open 1.01125, close. Go up into your exponent, and now your exponent is 40. So after 10 years, you will have 95,420. Since it's 26.9, we are going to round that up to $427. On this example, we have on Melissa's 6th birthday, she gets a $6,000 CD that earns 3% interest. It's compounded semi-annually. If the CD matures on her 16th birthday, how much money will be available? So we actually know everything that we need to plug in, because if she gets it on her 6th birthday and it matures on her 16th birthday, it has been invested for 10 years. So we are going to find A of 10, because the number of years it's been invested, which is the T, the time, is 10, equals the principal, which is how much she starts with, which is 6,000, times 1 plus the R, which is the interest rate in decimal form. So 3% in decimal form, which means the decimal is after the 3, and if I move it 2 places to the left, I'm going to have 0.03. So there's my R over the N. The N is the number of times it's been compounded per year, and if it is semi-annually, it's compounded twice a year. So that would be a 2. The N up here is also a 2, and then again, the number of years will be 10. So let's see what's inside that parentheses. I'm going to have 6,000 times 1 plus 0.03 over 2 gives me 1.015. My exponent is 2 times 10, which gives me 20. So I have 6,000 times 1.015, close, go into my exponent, and my exponent is 20. And on this one, I'm asked to round to the nearest cent. So I'm going to have $8,081. Cent means 2 places after the decimal. Since it's 0.130, I do not need to round up the 13 cents.